So today I'm going to show you how to use the factor of change for the kinematic equations. So we'll look at example 1. A ball is dropped from a height of h and lands in t seconds. A second ball is dropped from a height of 3h. How long does it take to land? So the first step is to write the kinematic equation in variable form that we're going to use. So we need an equation that relates the time in the air to the height of drop, given that it starts at 0 velocity. So the equation we're going to use is delta y equals v initial yt plus 1/2 at squared. And we know v initial y is 0, so I can cross that out. So this equation relates the height, which is delta y, and the time in the air, t. Rearrange the equation to determine the relationship between the two variables. So instead of putting y, delta y, I'm going to put in h equals 1/2 g, because that's acceleration, t squared. And it says, rearrange the equations to determine the relationship between the two variables. I'm going to get t by itself because I know it's 3h and I want to find out the new t. So t equals 2h over g square root. Step 3 says substitute a 1 for any variable or constant that is not changing. So 2 is a constant, it's not changing. G is a constant, it's not changing. So if I substitute a 1 in for both of those, I'm going to change this. I'm not going to put equals, I'm going to put a proportion, 1h over 1. So I get the square root of h. So basically I get t is proportional to the square root of h. Now step number 4 says replace the variable that is changing with the factor it is changing by and write as a proportion. So h is replaced with 3h. So the proportion that is changing by is 3. So I get t new, because it's my new t, is proportional to the square root of 3. Calculate the factor that the other variable changes by and solve. Well, t new is the square root of 3 times t original, or t old. So there's your first example. Let's look at a second example. A ball is launched upward with a velocity of v initial and angle theta. It reaches a maximum height h in time t. What happens to the maximum height reached and the time in the air if it is launched at 2 times the speed with the same angle? Okay, so going through the same thing, we have to figure out what equation to use. So it's launched upward with initial velocity. It reaches a maximum height. So we know at the maximum height, Vy equals 0. And they want to know what happens to the maximum height and time in the air if it's launched at twice the speed. So we need an equation. We're going to start with just what happens to the time in the air. We'll go with that one first. The time in the air at twice the speed. And we're going to look at that halfway point. So we're looking for a relationship between time and initial velocity. And we know v at the maximum height is 0, so we're going to choose this equation. Vy equals v initial y plus at. Well, we know the maximum height Vy is 0. We're going to rearrange this equation to solve for t. So 0 equals v initial y, and acceleration in this case is going to be negative, so I'm going to put minus gt. I'm going to solve this for t, and I get t is equal to v initial y over g. Okay, we rearrange the equation. The next is substitute a 1 for any variable or constant that is not changing. Well, g is not changing, so we could say that t is proportional to v initial y. And what happens to the maximum height? Oh, sorry. Replace the variable that is changing with the factor it is changing by and write as a proportion. So this is doubling the speed. So basically, T new is equal to 2T old. Because T is proportional to B and T is proportional to 2T old. Okay, the next part, let me move this down, is we have to figure out how that affects the maximum height. So I need an equation that relates maximum height to speed. And we also know that V at the top is 0. So I'm going to go with Vy squared equals V initial y squared plus 2a delta y. Again, we know that this goes to 0. So 0 equals V initial y squared. This a is negative, so it's going to be minus 2g delta y. I'm going to rearrange the equation because I want to know what happens to the maximum height, which I'm going to substitute in, instead of saying delta y, I'm going to call it h. Rearrange to solve for h, I get h equals v initial y squared over 2g. Step 3 is to substitute in a 1 for any constant or variable that's not changing. So I'm going to rearrange this. If I substitute in a 1 for the 2, a 1 for the g, I get h is proportional to v initial y squared. And the new v is twice the old v. So replace the variable that is changing with the factor it is changing by and write as a proportion. H is proportional to 2 squared. So H new is 4H old. And there you have it.